Good day, everyone. I'm here to report the overview of our topic, program input or output. Program input or output is one of the I/O technique adding the interrupt-driven I/O and direct memory access or DMA. This is one. This is the most simple type of I/O technique for the exchange of data or any types of communication between the processor and the external devices. With program I/O, data are exchanged between the processor and the I/O module. The processor executes a program that gives it control of the I/O operation, including sensing device status, sending a read or write command, and transferring the data. When the processor issues a command to the I/O module, it must wait until the I/O operation is complete. If the processor is faster than the I/O module, then this is a wasteful of processor time. Now, here is the overall operation of program I/O as follows. First, the processor is executing a program and encounters an instruction relating to the I/O operation. Second, the processor then executes that instruction by issuing a command to the appropriate I/O module. Third, I/O module will perform the requested action based on the I/O command issued by the processor, the read or write, and set the appropriate bits in the I/O status register. Lastly, the processor will periodically check the status of the I/O module until it finds that the operation is complete. Now that we know about that, let's learn more with my groupmates about the program input or output.
Hello everyone, my name is Luana May Solas and I'm going to report about the program I/O mode input data transfer. So the I/O subsystem of a computer. It provides an efficient mode of communication between the central system and the outside environment. It handles all the input and output operations of the computer system. So the input or output devices that are connected to computer are called peripheral devices. These devices are designed to read information into or out of the memory unit upon command from the CPU, and they are considered to be the part of computer system. Each input is read after first testing whether the device is ready with the input, a state reflected by a bit in a status register. The program waits for the ready status by repeatedly testing the status bit until all targeted bytes are read from the input device. The program is in busy, non-waiting state only after the device gets ready, else in wait state. And the next is a program I/O mode output data transfer.
Hello everyone, I am Angela Christine Camarines. So for today, I am going to report about the program I/O mode output data transfer. So first, let me define the program I/O. The program I/O was the most simple type of I/O technique for the exchanges of data or any type of communication between the processor and the external devices. So the external devices here is the output, where people is ready to read information such as the text-based file in an output devices like monitor, speaker, and printers. Or should I say the external factor of the computer. So in this illustration, you will see in number 1 that the output written after first testing whether the device is ready to accept the bytes at its output register or output buffer is empty. So in number 4, the program waits for the ready status and repeat testing the status until all the targeted bytes are written to the device. Lastly, the program in busy state after the device gets ready else wait.
Hi everyone, I am January NBT, and this time I am going to discuss about the inputs or outputs commands. So in order to execute an I/O related instruction, the processor issues an address specifying the particular I/O module and external device and an I/O command. There are 4 types of I/O commands that an I/O module may receive when it is addressed by a processor. First is control, test, read, and write. So first, let's tackle about the control. Control is used to activate a peripheral and tell it what to do. For example, a magnetic tape unit may be instructed to rewind or to move forward one record. These commands are tailored to the particular type of peripheral device. Second is test. Test is used to test various status conditions associated with an I/O module and its peripherals. The processor will want to know that the peripheral of interest is powered on and available for use. And also, test is very important because it will let us know if the most recent I/O operation is complete and if any errors occurred. Third, read. Read causes the I/O module to obtain an item of data from the peripheral and place it in an internal buffer. The processor can then obtain the data item by requesting that the I/O module place it in the data bus. Last is write. Write causes the I/O module to take an item of data from the data bus and subsequently transmit that data item to the peripheral. And now let's proceed to input or output instruction. So, with programmed I/O, there is a close correspondence between the I/O related instruction that the processor fetches from the memory and the I/O commands that the processor issues an I/O module to execute the instructions. Typically, there will be many I/O devices connected through I/O modules to the system. Each device is given a unique identifier or address. When the processor issues an I/O command, the command contains the address of the desired device. Thus, the I/O module must interpret the address lines to determine if the command is for itself and also which external devices that the address refer to. When the processor main memory share a common bus, there are 2 possible modes of addressing. These are memory mapped I/O and the isolated I/O. When addressing with memory mapped I/O, there is a single address space for memory locations and I/O devices, and the processor treats the status and data registers of I/O modules as the memory locations and uses the same machine instruction to access both the memory and I/O devices. So, in memory mapped I/O, a single read line and a single write line are needed in the bus. While on the other hand, the isolated I/O, there are only a few I/O instructions, and isolated I/O have common bus for I/O and memory, but separate read and write control lines for I/O. So when the CPU decode instruction, then if data is for I/O, then it places the address on the address line and set I/O read or write control line on due to which data transfer occurs between CPU and I/O. As the address space of memory and I/O is isolated and the name is so. The address for I/O here is called ports. Here, in ports, we have different read-write instruction for both the I/O and the memory. So to fully understand the two modes of addressing, I have here the differences between the two. So first, let's tackle about the isolated I/O. In isolated I/O, memory and I/O have separate address space. Second, all address can be used by the memory. There is also a separate instruction control, read and write operation in I/O and memory. And then the I/O address are called ports. And then isolated I/O is more efficient due to separate buses and is larger in size due to more buses. While on the other hand, the memory mapped I/O both have the same address space. And then due to addition of I/O addressable memory become less for memory. And then there is same instructions can control both the I/O and memory. And then normal memory address are for both. And memory mapped I/O is lesser efficient and smaller in size, unlike to isolated I/O. So that's all. Thank you.
The advantages and disadvantages of program I/O. So the advantages here is that it is simple to implement. So this technique is straightforward and simple. Very little hardware support. It could be used when there is no performance requirements or the I/O devices are very fast and not too many. The disadvantages here is that it consumes a lot of time. So it is busy waiting, ties up CPU for long period with no useful work. So the CPU waits the I/O device in a loop and pulling becomes inefficient when it is attempted repeatedly, yet rarely finds a device to be ready for service, while other useful CPU processing remains undone.